Okay friends, today we will discuss electric potential energy, change of electric potential energy. Now the first question from section review, it says what is the difference between delta potential energy and the potential energy? When we check it, when we say delta, look at here, delta means a change. So when we say delta potential energy, it is equal to minus QED and PV. Potential energy final minus potential energy initial. So delta PE, delta potential energy is the change of potential energy between 2 points. When we say delta, it is the change between 2 points. But when we say just potential energy, for example, its initial position we can assume as 0. So initial potential energy can be 0. When we say potential energy, it means potential energy at a point. So difference between them is PE is the potential energy at a point, delta PE is the change between 2 points. Second one, in a uniform electric field, what factors does the electric potential energy depend on? Okay, it is charge, electric field strength and the displacement in the direction of the field or distance that the particle move in the same direction as field. Remember how we calculate, it says electric potential energy. So delta potential energy, how we calculate it, it is equal to minus Q, E and the D here. Q is the charge, E is electric field, and D here, distance or displacement you can use. Third one, describe the conditions that are necessary for mechanical energy to be conserved. We said electric potential energy is also a kind of mechanical energy. So here mechanical energy is conserved in the absence of friction and then radiation. Mechanical energy is conserved in the absence of friction and radiation. Third one, is there a single correct reference point from which all electric potential energy measurements must be taken? No, in all potential energy, a reference point is important. So first our answer is no. And as I say, it depends on the reference point where we choose. So in such potential energy, we can choose reference point. Mostly the initial point is accepted as 0 level. Let's pass 5. I have solved it before. I will start with problem 6. What is the change in the electric potential energy in a lightning bolt if 35 coulomb charge travel to the ground from the clouds? That's 2 kilometers above the ground. What is given here? 35 coulomb charge is given. Let me change my marker. Charge is given. Charge 35 coulomb. And then the distance is given. D is equal to 2 kilometers, 2.0 it says. We have to change it to meter. When we multiply it by 1000, it will be 2000 meters. And then assume that the electric field is uniform between the cloud and the earth, and an electric field is given. It is equal to 1.0 10 to the power of 6 Newton per coulomb. So change in the potential energy wanted. What is the change in potential energy? So delta PE wanted. It is equal to minus Q, E and D. Delta PE is equal to Q is given 35 coulomb multiply electric field is given 1.6 1.0 10 to the power of 6 Newton per coulomb and multiply D, it is 2000 meter. 2000 meter. And delta potential energy will be here. As you see, Here, Coulomb and Coulomb cancelled. Newton meter will be joule. So delta potential is equal to minus 7.0, 10 to the power of 10, 10 to the power of 10 joule. Another question. 7. The gap between electrodes in a spark plug is 0.06 centimeters. D is given, it is equal to 0.06 centimeter. If we convert it to meter, it will be 0.0006 meter. I divide it by 100. And then assume that it requires an electric field of 310 to the power of 6 volts per meter. It requires an electric field of 3.010 to the 6 volts per meter. And then it says, what is the minimum potential difference? Delta V wanted here. What is the relation between potential and the electric field? Delta V is equal to minus ED. And then delta V is equal to minus E is 3.010 to the 6 multiply D is 0.0006 meters. When you multiply them, you can get delta V as delta V is equal to minus 1800 volt. That is the potential difference. It says what is the minimum potential needed, so we can say that delta V is equal to 1800 volt is needed. If you leave minus 1800, it doesn't matter, it is also correct. 8. A proton is released from the rest in a uniform electric field, a magnitude with a magnitude of 8, 10 to 4 electric field given. Electric field is equal to 8.0, 10 to the power of 4. 10 to the power of 4 volt per meter. And the proton is displaced 0.5 meters. It says here, pay attention, the proton is displaced. It is moved by the field. Find the potential difference. A, the potential difference wanted, delta V, wanted. B, it says find the change in electric potential energy. Delta PE wanted. Now let's start with A. As we did before, delta V is equal to minus ED, and delta V is equal to minus E is given 8, 10 to 4, 8 multiplies 8.0, 10 to the 4 volts per meter, multiply 0.5 meters. And the meter and meter will cancel, then delta V will be minus 4.0, 10 to the power of 4 volt. This is the potential difference. So when we write delta potential between them, it will be 4.0, 10 to the 4 volt. Second, in section B, what is wanted? It says calculate delta potential energy. Delta potential energy is equal to Q multiply delta V and And then delta potential energy is equal to Q is given. What is Q? It is proton, so 1.6 10 to minus 19 coulomb multiply B. B is 410 to 410 to the power of 4 volt. Here delta V we say, so minus 410 to the power of 4. When you calculate change in potential energy, will be minus 6.4 10 to the power of 15 minus 15 joule. Minus 6.4 10 to the minus 15 joule. Here proton moves from high potential to low potential, so potential energy, change in potential energy is negative. 9. In a thunderstorm, the air must be ionized by a high voltage before a conducting path for a lightning. An electric field of 1.10 10 to 6 volt per meter is required. Electric field given, it says 1.0 10 to the 6 volt per meter of an electric field is needed to produce lightning. And then it says the distance 1.6 kilometer, distance 1.60 kilometers, and it is equal to 1,600 meters. Calculate breakdown potential voltage delta V wanted. Delta V is equal to minus ED, and delta V is equal to E is given as 1.0 10 to the power of 6 multiply. D is 1,600. Use your calculator, then you will get delta V as minus 1.6 10 to the power of 9 volt. This is the potential that is needed.